Hello student, I am Dr.A.K and today I am going to discuss ionic or electrovalent bond. It is very important. What is ionic bond? Now I am telling. From the Kossel and Lewis treatment of the formation of an ionic bond, it follows that the formation of ionic compounds would primarily depends upon first the ease of formation of positive and negative ions from the respective neutral atoms. Second, the arrangement of positive and negative ions in the solid, that is the lattice of the crystalline compound. The formation of a positive ion involves ionization, that is removal of electron, 1 electron, 2 electron, 3 electron, like that way from the neutral atom, and that of the negative ion involves the addition of electron or electrons to the neutral atom. As for example, suppose in general metal will lose 1 electron, then it will give M plus, capital M plus, M means metal, M plus in gaseous state, plus electron. M plus, sometimes 1 plus, sometimes 2 plus, sometimes 3 plus, and it requires energy. Then that is called ionization enthalpy. And just like for an ion, suppose X is there in gaseous state and it takes 1 electron, then it will form X minus in gaseous state. That is called electron gain enthalpy. And when cation and anion will be formed, then both will join. Positive and negative means cation and anion both will join in gaseous state and it will form Mx, means salt it will form. Mx, solid they will form. The electron gain enthalpy, that is the delta H, is the enthalpy change when a gas phase atom in its ground state gain an electron. The electron gain energy delta H is the enthalpy change when a gas phase atom in its ground state gains an electron. The electron gain process may be exothermic or endothermic. The ionization, on the other hand, is always endothermic. I am repeating, ionization is the always endothermic. Electron affinity is the negative of the energy. Electron affinity, electron gain enthalpy and electron affinity, minor changes there. Electron affinity, know about the electron affinity. Electron affinity is the negative of the energy change accompanying electron gain. This is the difference. Okay, electron gain enthalpy may be positive or negative, delta H may be positive or negative, but here in electron affinity is the negative of the energy change accompanying electron gain. Both are related to electron gain only. When positive, negative, both you are thinking, considering, then it is called electron gain enthalpy. When you are considering only negative of the energy change accompanying the electron gain, that time it is called electron affinity. Obviously, ionic bonds will be formed more easily. Ionic bond is formed more easily between elements with comparatively low ionization enthalpies and elements with comparatively high negative value of electron gain enthalpy. This is the condition. Again, I am telling, ionic bonds will be formed more easily between elements with comparatively low ionization enthalpies and elements with comparatively high negative value of electrons gain enthalpy. This is the main condition. Most ionic compounds have cations derived from metallic elements and anions from non-metallic elements. The ammonium ion, as for example NH4 plus, it is made up of two non-metallic elements. In an this ammonium formation of ammonium, that is exception. Here the ammonium ion made up of two non-metallic elements. Nitrogen is non-metallic, and here hydrogen also, actually total NH4 plus is there, then it is a hydride ion, it will take electron. Hydrogen here, it will take electron. Hence, this time when they are in hydride ion, they are taking electron, then that time it is treated as halogen. Hydrogen has two places. Group 1, when it will lose the electron, that time it will be with group 1. And when it is accepting one electron, then that time it is treated with, or it belongs to halogen. It has two groups, group 1 and group 7. Then here in ammonium ion, here hydrogen accept the electrons. Hence you can tell nitrogen and ammonium both belong to the non-metallic elements. This is an exception. Generally in bond formation, one will be of metallic, other element will be non-metallic. But here ammonium is the exception, and this question is important, asked. Formation of ammonium. Ionic compounds in the crystalline state. Ionic compounds in the crystalline state consist of orderly three-dimensional arrangement of cation and anion held together by Coulombic interaction energies. Here just I am talking about the ionic compounds, particularly ionic compounds in the crystalline state. Crystalline state, they will be in three dimensions, means length, breadth, height, and they will be arranged like that: positive, negative, positive, negative, positive, negative, like that way, lengthwise, again height wise also same way. Two same charge will not come close. Always between the two same charge, one opposite charge will come. As for example, between the two Na plus, between that Cl minus will come. Then whole arrangement, it will be like that. Two same charge will not come closer. Always it will come in the middle, opposite it will come. That's why in arrangement will be like that, particularly in sodium chloride, Na, then Cl, then Na, then Cl, then Na, then Cl, like that way, lengthwise also, breadthwise also, height-wise also, length, breadth, height. Then all arrangement will be like that, that two same charge ion should not come close. Always in the between some opposite charge should come. This is the special things I have told you. That ionic compounds in the crystalline state consist of orderly three-dimensional arrangement of cation and anion held together by a Coulombic forces or Coulombic interaction energies. These compounds crystallize in different crystal structure determined by the size of the ions, their packing arrangement, and other factors. This may be different molecules may have different arrangement, different size. Their this size will be different, and even their packing arrangement will be different. The crystal structure of sodium chloride is common. NaCl, I have told you. NaCl is also called rock salt. Now, in ionic solids, the sum of electron gain enthalpies and the ionization enthalpies may be positive, but still the crystal structures gets stabilized due to the energy released in the formation of crystal lattice. Actually, in any ionic solid, the sum of the electron gain affinity and the ionization enthalpy may be positive, but still the crystal structure gets stabilized. Why and how? Then this happens due to the energy released in the formation of crystal lattice. Because energy release means more stable. Energy release means that in molecule energy should be less. Then they will be stabilized. Then during formation energy is released. That's why crystal will be stable. For example, the ionization enthalpy of sodium ion means in gaseous state, Na plus in gaseous state, sodium plus formation from sodium ion, it will lose the electron, then it will form sodium ion Na plus. That time it releases 495.8 kilojoule per mole. Per mole means Avogadro number. Then 495.8 kilojoule per mole. Okay, that is the ionization enthalpy for sodium ion. While the electron gain enthalpy of for the change of these things CH, not Cl we consider, chloride Cl, that is the chloride ion. When it will take electron, then that is the electron gain enthalpy. Either it will release or it will absorb the energy. That is called electron gain enthalpy. Then chloride ion in gaseous state, chloride ion, when you will take one electron, then it will form chloride ion in gaseous state. Both are in gaseous state. Then that time it will absorb 348.7 kilojoule per mole. Then here see two example I given you. Sodium, when it releases one electron in gaseous state, then it will release 495.8 kilojoule per mole, means exothermic reaction. And when chloride ion takes one electron in the formation of chloride ion in gaseous state, that time it absorbs 348.7 kilojoule per mole only. Then if you will add both, the sum of the two, then you will find 147.1 kilojoule per mole is more. Means sodium chloride, what they release the more, and what chlorine atom absorb, that is the less. Correct? That is a more. This for difference between two is coming 147.1 kilojoule per mole is more than compensation by the enthalpy of lattice enthalpy of lattice formation of NaCl, that is equal to 78 kilojoule per mole. NaCl, when NaCl will form, that time it will actually, that is called enthalpy of lattice formation. Enthalpies of lattice formation, then that time it will involve 788 kilojoule per mole. Then I told you that when you will add for chloride ion formation and sodium ion formation, that time energy released or energy absorbed, then difference is only 147 means plus 147 kilojoule per mole. This energy is more than the compensated by the enthalpy of lattice formation of NaCl. Okay. Therefore, the energy released in the process is more. Energy released during the process of you can say formation. The energy released in the process is more than the energy absorbed. This is the important thing, sir. Energy released in the process is more than the energy absorbed. Thus, a qualitative measure of the stability of an ionic compound is provided by its enthalpy of lattice formation and not enthalpy by achieving octet of electrons around the ionic species in gaseous state. Okay, means this is more convincing that qualitative measure of the stability of ionic compound. According to Lewis, they have given importance for the octet, but here this energy qualitative measures of the stability of ionic compound is provided by its enthalpy of lattice. Enthalpy of lattice is more convincing, more important. And enthalpies of lattice formation is more, you can say, responsible than the octet rule. Correct? Qualitative measure of the stability of an ionic compound is provided by its enthalpy of lattice formation and not simply by achieving octet electron around the ionic species in gaseous state. Okay. Since the lattice enthalpies play a key role in the formation of ionic compounds, it is important that we should know more about it. Now, I am defining what is the lattice energy. Lattice energy or lattice enthalpy. Lattice enthalpy. The lattice enthalpy of an ionic solid. The lattice enthalpy of an ionic solid is defined as the energy required to completely separate 1 mole of a solid ionic compound into gaseous constituent ions. This is the definition for lattice enthalpy. The lattice enthalpy of an ionic solid is defined as the energy required to completely separate 1 mole of solid ionic compounds in a gaseous constituent ions. Means if solid is there, then how much energy is required to separate out all atoms you are separating out in gaseous state. in the form of ions. Correct? Suppose NaCl is there, Na plus Cl is there, 1 mole of NaCl you are heating, then how much energy it is releasing completely in bringing it to the gaseous state. That energy is called lattice energy or lattice enthalpy. For example, the lattice enthalpy of NaCl is 788 kilojoule per mole. This means that 78 kilojoule of energy is required to separate 1 mole of solid NaCl into an 1 mole of Na plus gaseous state and 1 mole of Cl in gaseous state. To an infinite distance between Na and Cl, gap should be there, too much gap. Then only you can tell it is in vapor state. Then NaCl, how much 1 mole of NaCl you have taken, then you have separated it into sodium ion, 1 mole sodium ion, 1 mole chloride ion. Obviously 1 mole NaCl is there. Then 1 mole, it will give 1 mole Na plus ion, 1 mole Cl ion. Then how much energy is required to, from the solid you have brought it to the gaseous state, from the ground state to the gaseous state. Then that time how much energy is required? That energy is called lattice enthalpy or lattice energy. This process involves both the attractive forces. This process involves both the attractive forces between the ions of opposite charges and the repulsive forces between the ions of like charges. The solid crystal being three-dimensional, it is not possible to calculate the lattice enthalpy directly from the interaction of forces of attraction and repulsion, because it is three-dimensional, and it is difficult to calculate the these things. This is directly by interaction. We can't calculate the enthalpy. To calculate lattice enthalpy directly from the interaction of forces of attraction and repulsion is not possible. The solid crystal being three-dimensional, it is not possible to calculate lattice enthalpy directly from the interaction of forces of attraction and repulsion. Only you can say factors associated with the crystal geometry have to be included. Okay, here to calculate, for the calculation of lattice energy, you can say some factors are there that you have to consider, and only then you can calculate what are the factors, like bond length, bond angle, bond enthalpy. These are the, you can say, factor you have to consider if you are going to calculate the lattice enthalpy. Okay, now I want to tell you, now you just discuss about the ionic or electrovalent bond. Then just before going ahead, I will tell you what is the ionic bond. Ionic bond, in ionic bond there is a complete transfer of electron. In covalent bond we have seen there was sharing of electron 50-50. They have not given direct electron to the others, just in the middle both came sharing. But here in ionic compound, that is a complete transfer of electron from one atom to the other. Means electronegative, they will take electron fully. That's why this one will lose the electron, then it will become positive charge, other will take the electron, then negative charge, then positive and negative charge developed. And this, due to this development of charge, opposite charge, they are attracting to each other. Then this force of attraction is called ionic bond. Then ionic bond is nothing but a force of attraction between two oppositely charged species. Okay, ionic bond is stabler than covalent bond, more stronger than covalent bond. You keep in mind. And then this is the I told about the in a shortcut about the ionic bond and why it is called electrovalent bond. Ionic bond is also called electrovalent bond because here charge is developed. Electrovalent means that it is related to the transfer of electron. Completely there is transfer of electron. Now I am going to tell about the bond length. Just they are asking in this bond length, what is the bond length, then you should understand. Bond length is defined as the equilibrium distance between the nuclei of two bonded atoms in a molecule. It's very simple. Bond length is defined as the equilibrium distance between the nuclei of two bonded atoms in a molecule. Bond lengths are measured by spectroscopic. By a spectroscope it is measured, or X-ray diffraction or electron diffraction technique, about which actually these are the difficult things how to measure. This is studied in higher classes, but I am telling you this bond length are measured by a spectrometer, a spectroscopic technique, X-ray diffraction technique or electron diffraction technique. Okay, each atom of the bonded pair contributes to the bond length. Each atom of the bonded electron pair contributes to the bond length. Okay, in case of a covalent bond, the contribution from each atom is called the covalent radius. Here it is called ionic radius. Okay. Now the covalent radius, how will you measure? The covalent radius is measured approximately. The covalent radius, here I told you bond length is defined as the equilibrium distance between the nuclei of two bonded atoms. Nuclei, distance between nuclei of two bonded atoms in a molecule. But here covalent radius I am talking about. The covalent radius is measured approximately as the radius of an atom's core, which is in contact with the core of an adjacent atom in a bonded situation. Already I have discussed previous classes. The covalent radius is half the distance between the two similar atoms joined by a covalent bond in the same molecule. This is I told about the covalent radius. New things I am going to tell you, that is the van der Waals radius. Because covalent and van der Waals both are somewhat similar. That's why here I am repeating you covalent radius. Now just come to the van der Waals radius. What is this? The van der Waals radius represents the overall size of the atom, which includes the valence shell in a non-bonded situation. Non-bonded situation means valence shell is there, electron is there. That time obviously its size will be more. When valence last orbit is not there, then size will be small. But here in van der Waals forces you are considering, that is the non-bonded situation, and that valence shell you are considering. The van der Waals force radius represents the overall size of the atom, which includes the valence shell in a non-bonded situation. This I have told about the van der Waals radius. Okay. Then bond length I have told you. Now you can see this little more. average bond length actually is generally the term average bond length is considered for single bond, double bond, triple bond. Single bond actually single bond, double bond, triple bond. Triple bond will be the strongest. Double bond will be a stronger. Single bond will be a stronger, strongest. And as the you can say bond length increases, bond length is more means bond is weak. Bond length is less means strong. Very less means more stronger. Why it happens is important things I am telling you. If bond length is more, means they are far from each other. Hence easily it can be separated or can be broken. That's why less energy will be required. Bond will be weak. Double bond means if it is a bond length is small, means both are close. It means attractive force is more. Attractive force is working more. Hence bond will be stable. Due to the more attractive force, bond will be strong and distance will be less because both are becoming closer. And like that way, single bond length will be more than double bond. Double bond bond length will be less and triple bond further less. That's why single bond is weak, double bond is strong, and triple bond is stronger. And here I want to tell you why two atoms are not touching to each other. Always they will maintain some distance. This I am telling again very important thing, concept, that two atoms in a molecule, they will not touch to each other. They will make distance. Why they are making distance? Then because in the atoms same charge, with suppose two atoms are there, then one in both atom electrons will be there, in both atoms proton will be there, or nucleus will be there. Nucleus is positively charged. Then in the same charge repulsion will be there. Means electrons of both atoms will repel to each other and both nucleus will repel to each other. That's why due to the repulsion they will make you can say distance. But due to the attraction, means positive and negative. Positive and negative. Nucleus is positive, electron is negative. Nucleus of first atom. Nucleus of first atom and electrons of second atom, both will attract. Like that way, nucleus of second and electrons of first, both will attract. Like this way, due to the attractive force, they want to come together. But same times, due to repulsion, they want to make distance. That's why they will make you can say some distance between the two. Due to the attractive force, they want to come closer, but due to the repulsive force, they want to make distance. Hence, resultant force that you can say distance will be maintained. Now I am going to tell about the bond angle. Bond angle, what is the bond angle? Then it is defined as the angle between the orbitals containing bonding electron pairs around the central atom in a molecule or complex ion. Again you see that central metal ion means between, suppose 3 electrons are there. The question arises for a bond, at least 3 atoms will be there. One will be in the middle. That is called central metal ion. That will be metal only. and two other, that is called ligands. Like you can say, suppose you are considering water molecules, H2O, then O will be in the middle, and H, 2H is there, then they will make just like a V-shaped, then both will be in the two corner. Like that way NH3 is there, the N will be in the middle and both H will be in the corner. Then they will make some angle. Question of angle arises when three atoms are there. Then bond angle is defined as the angle between the orbitals containing bonding electron pair. Orbital automatically will have, you can say, electrons. Then this angle between the orbitals containing bonding electron pairs around the central atom in a molecule or complex ion, that is called angle, bond angle. Again I am telling you, bond angle is defined as the angle between the orbitals containing bonding electrons pairs around the central atom in a molecule or complex ion. Bond angle is expressed in a degree. Just like any angle you are measuring the degree, like that way, which can be experimentally determined by same technique what I told you, a spectroscopic technique. And it gives bond. What is the, why we are studying here bond angle? Then bond angle, what is the purpose of studying? It gives some idea regarding the distribution of orbitals around the central atom in a molecule or a complex ion, and since it helps us in determining its shape, what type of shape will be there. Then suppose angle between the angle is suppose 60 degree, then you can understand what type of molecule will be there. If angle is 180 degree, then it will be a straight line, linear, that is called linear. Then between the angle will decide about the shape of the molecule. That's why it is important. Here in water molecules, H2O, it is just like a V-shaped. OH, two OH bond is there. Between the two OH bond, oxygen in the middle, angle is 104.5 degree. Okay. This I have told about the bond angles. Now I will focus about the bond enthalpy, means bond energy. Then it is defined as the amount of energy required to break 1 mole. Always 1 mole you have to consider. Okay. It is defined as the amount of energy required to break 1 mole of bonds of a particular type between two atoms in a gaseous state. Okay. How many bonds are there in 1 mole? Water is there, 1 mole water you have taken. Then in 1 mole water is a big quantity. Many bond will be there. H2O, so many H2O will be there. Avogadro number, Avogadro number. That number of molecule will be there, the big number. Then then obviously many bond will be there. Then that how much energy is required to break this bond? How many energy required to break all bonds present in 1 mole of water? That energy is called bond energy or bond enthalpy. Then it is defined as the amount of energy required to break 1 mole of bonds of a particular type between two atoms in a gaseous state. The unit of bond enthalpy is kilojoule per mole. Okay, per mole how much energy is required. Now further, just example I told you, hydrogen, H example also you can take, hydrogen. For example, HH bond enthalpy of hydrogen molecule. Hydrogen between the two hydrogen is there, H2. Then If you want to break 1 mole of hydrogen, not only one molecule HH, 1 mole Avogadro number, 6.022 into 10 to the power 23 molecule, big number is there. Then if you want to break all HH bond, then it requires 435.8 kilojoule per mole. Similarly, the bond enthalpy of molecule containing multiple bond, then multiple bond means a strong bond. As for example, oxygen O2, OO, NN means nitrogen, NN. Then for oxygen, if you want to break O2 into O plus O like that, 1 mole, then that time it will release energy delta H will be 498 kilojoule per mole. It releases it required delta H is plus. Plus means endothermic. Heat is, you have to supply heat. Delta H minus means exothermic, heat is releasing. Then it will absorb the heat in case of oxygen, hydrogen, everywhere. Then delta they are absorbing, that's why delta H is plus. Here 498 kilojoule per mole in case of oxygen. Like that way for nitrogen 3 bonds are there. It is very strong, very stable. Nitrogen, NN, between the NN triple bond is there. Then obviously they will require very high energy. Then that is 946 kilojoule per mole. If nitrogen you want to break into NN, then that time it requires a very high energy for 946 kilojoule per mole. It is important that larger the bond dissociation enthalpy, stronger will be the bond in the molecule. Already I have told you. For a heteronuclear diatomic molecules, hetero means different type of molecules. This was the homo, OO, NN, HH, this was homo. But hetero means different. Then like HCl, 1 mole, you want to separate into the gaseous form. And that time it will require 431 kilojoule per mole. HCl is in gaseous state and you want to break into H and Cl. H and Cl in gaseous state. All this will you have to consider in gaseous state only. Okay, gaseous state only. Then that time for HCl 431 kilojoule. It will break into H and Cl ion in gaseous state. In case of polyatomic strength, poly means many, you know. In case of polyatomic molecules, the measurement of bond strength is more complicated. For example, in case of H2O molecules, the enthalpy needed to break the two OH bonds is not the same. H2O is there, na? O is the in center, HH is there. But here very things are there. A question is asked, very tricky, that OH, two bond is there, then both will not take the same energy to break. Both OH will take different energy. A very intelligent question, and in IIT and in it of examination it is asked. OH, you will think it will take same energy to break. No. What happens here? First OH will break. That time it will require more energy. That is 502 kilojoule per mole. But second, after breaking, it will break into H plus OH minus. It will break H plus OH minus. Then in this process, 502 kilojoule per mole energy required. But from that OH minus is there, OH, hydroxyl ion. Now again you want to break it into the, you can say O and H. Then that time it will require less energy, 427 kilojoule per mole. Then what